to use when you need to work with many similar or related values. Lists can hold any type of value. This includes int, strings, booleans, lists, and even classes, a topic which we'll be going over later today. How do you use them? Well, a list is a type of variable, therefore it is defined like any other variable. Like all other variables, you need to give it a value. For list, you put square brackets. This is similar to defining a string with quotation marks. Inside of the brackets, you can put whatever you want to be inside of your list at the start. Each value should be separated by commas. You can put as many as you want. So here's an example of fruits. See how all of them are separated by commas? So I said they can store pretty much anything, and here are some examples. Here's a bunch of whole numbers, decimals. Here are some strings. Here are some booleans. And while not good practice, you can mix up what you're storing. So here you have a int, a float, a boolean, and a string. So one of the more important things about lists are the functions you can do on them. So let's go over them. The first one is del. Del stands for delete, and how it works is you type del space the list name with in square brackets the index you want to delete. Let's go over here and see. If anyone has any questions at any time, please ask. So let's define a list with square brackets, and let's put some ints inside. So with del, you would do del L at whatever index. So if you want to delete the first element, remember that's index 0 because the first one is 0. And let's print it out. See, the first element has been deleted. If you want to delete the third element, 1, 2, 3, well, since it starts with 0, 0, 1, 2. So, oops, print del. And the third element, which is 6, has been deleted. Well, let's continue to the next one. List.remove. This removes the first X inside of the list. Well, that might be a bit confusing to read, so let's look at it. So let's say I want to delete 6. I want to delete 6 from that list, so I do dot remove 6. And as you can see, 6 has been deleted from the list. If I want to remove 8, you do l.remove 8, and it's gone. Now, if you have some more 6s, and you do .remove 6, it will not remove all of them. It will only remove the first one, which was supposed to be here. As you can see, it's missing. So here you just put the value. And if it's a list of strings, do the same thing. And C has been deleted. The next one is .append. .append takes in value X and will append X to the end of the list. Well, let's try it. L.append. Let's continue the alphabet D. And as you can see, D is at the end of the list. This works with ints, booleans, and pretty much anything you can think of. Now, the next one is similar to .append. However, it's a bit more versatile. .insert. .insert takes in I as well and X, and it will insert X at index I in the list. Well, what does this mean? Well, let's see. L.insert. First, it takes an index, so let's insert something at index 4, which would be 0, 1, 2. Well, you can't do 4, so let's try 3, which would be right after C. And then you put D. And you might think, isn't this the same as append? Well, no, because you can put index 0 and it will insert it right here. Insert it before A. So this means that everything afterwards will have their index shifted by 1, and it will put it right before. So index 1 would be 0, 1. It'll be before this, so it'll be right here. Let's try running it. And D is right there where we said it would be. So this is how you use insert. It's a lot more versatile because you can choose where you want to put it. However, if you want to put it at the end and you don't know the length, it's a lot more complicated. You have to do len of L, and it takes a lot more writing than dot append. So it has its use cases, and dot append also has its use cases. List name dot index of X. This finds the first index of X inside of a list. So let's see, I want to find dot index of A. Let's print this out. 0, right? This is index 0. So let's try finding C to be 0, 1, 2. Now let's try finding the index of D. As you can see, D does not exist in this. So what will it give us? An error. D is not in list. So how do we fix this? Well, to find out if a list contains something, use in. It returns true if X is inside a list, otherwise false. So how do you use this? X in list name. So let's try printing out if D is inside of this list. So X, or D in this case, in list, or L. And we should expect false. Yeah, false. A, true, because A is the first one here. So you can use this in combination with the previous one, or also remove, because remove will also give an error if you're trying to remove something non-existing. So you could do if D in L, L dot, well, let's try reloading. If you're having trouble with REPL, sometimes reloading the page will work. All right, let's rewrite what I just wrote. So remember the value you're trying to find inside of the list. Then print otherwise. So this can be used to prevent errors. And if you were to change both of these to A, you would get the index. Now you could write this into a function if you wanted to, but you don't need to. All right, and the last one is len list name. And this just gives the length of the list. You've already seen me use it before when I was presenting this, but it's pretty simple. Print len parentheses L, because it's a function. And 3, like we expected. 1, 2, 3. All right, now let's do a quick Kahoot. Remember, to go into Kahoot, it's kahoot.it. I'll give you a few minutes to come on in, and then I'll start. Also, if anyone has any questions on what I just presented, please remember to ask in the chat or DM anyone who has Paly Robotics in their name. Please type in chat if you're not in. We'll be starting very soon. All right, I don't see anyone saying that they're not in, so I'll give you a few more seconds and we'll start. All right, let's start. All right, good job. Everyone seems to have got this one. Just so you remember, it's list name followed by an equal sign and square brackets. Good job, everyone. Just so you know, some of the problems will have multiple answers which are correct. All right, so append is the most simple solution, and it'll just put it at the end. You can do the green one. You can insert at the end. This will also work. However, it's a lot more typing, so you probably should do this one. But if you have a reason to use this, it will work. Add is not going to do anything. In other languages, maybe it will. I don't know. But in Python, append is the way to add to the end. Attach, luckily no one got that. It has nothing to do with this. All right. So my list.remove item will remove a specific item from the list, like I said before. Delete is not the proper one, just so you know. Well, okay, skip the side. And zap, luckily no one got that one. Pop is for lists as well, but we haven't gone over it and it does not delete a specific one. All right, so for length, you do not put .len. Like I showed before in REPL, it's len. Len is the function, and then you put the list inside of it. Dot length is, if you've coded in any other language, not any other, but in some other languages such as Java, dot length is one of the ways to find the length of a list. However, in Python, use len as a function like this. Good thing no one got this one. And this one, just remember, it's a function like print. All right, so like I showed in REPL, you do mylist.index and then the item. It will give you the first item inside of your list. Dot position, it's not how you do it, it's index. Luckily, no one got dot item position, because if you already knew the position, I have no idea why you're doing this. And dot item is not what, it doesn't give you anything. It's not a function for lists. And if you already know the index, then there's no reason to do this. All right, so no one got this one correct. That's not that good. So let me go back to REPL. So print a or item in list, which is L. This will print true. The other options, my list or L dot in a. Error because that doesn't exist. So it is not blue because it's written like this. It's not a method or a function like that. Contains, it will also give you an error. So here you can see list object has no attribute contains. And the last one, no one got that wrong, so there's no reason for me to go back to REPL. So remember, item, what item you want to find in list. All right, so let's see. So this first one, let me copy this over. And let's see what happens. So my list is L, or I'll just call this my list for simplicity. And remove len at my list -1. What's going to happen? X is not in list, because this, if I print this out, you'll see that this is 2. It's a number. 2 is not in this list. The correct one, or correct ones, will be del, because del takes my list and an index. This is an index. This is your list. So this will work. And remove takes a value. So you'd have to do my list at this place. So this would say This would give you the last element, the index of the last element. This will give you the last element, and this will remove the last element. However, this is not always going to work if you have two C's inside. Oops, wrong one. Also, this one, I see a lot of you put this one. The reason this would not work is because if you remove this -1, this will delete something at index 3. So if we go 0, 1, 2, but there's no 3 here. So it'll give you index out of range. All right, good thing no one put deletes. So these two options, the reason they work is del at mylist3 will delete at index 3. And remember, it starts at 0. So the fourth element would be 0, 1, 2. Here, let me show you. If you have 4 elements, D as well, the fourth element will be at index 0, 1, 2, 3. Del mylist of 4 would not work because that would be out of, well, in this case, it'd be out of range, but it would just delete the fifth element. All right. All right. Most of you got this right, but for these ones, how do you insert an item at the start of a list? This one, let's do it here. Dot append item, let's put A, B, C, D, E. And what this will do, and let's print it out. This will append to the end. Append always goes to the end, but here at the start of a list. So we want it here. So dot insert item comma 0. Well, you might think this would work because insert at 0. However, no, this would insert at item a 0. So unless item is 0, it will not work. So let's see. Let's say I want to insert z at 0. It's going to give an error because string objects are not an integer. Now, this one we haven't taught you yet. Well, maybe you remember I did mention it on day 6. However, this will insert at the start. However, this is not that important. This is the best way to do it. And the reason this is better than, or not better, the reason this works compared to the this one is because index goes first. So it's index, then followed by what you want to insert. And here we can see it works. All right, next one. That's it. Good job. Good job, everyone. So because a lot of you didn't seem to get these wrong, so I'm going to go over here and show you this again. So remember, del, you put del followed by the list, and then the index you want to delete. So if you want to delete element at index I, you would do it like this. Del list name, then square brackets with I inside. This will delete element I from the list. List name.remove removes the first mention of X inside of the list. So if you have 1, 2, 3, 4, 5, 4, and do list.remove 4, it will only remove one of them and the first one to see. Dot append X appends X to the end of list. So never append it anywhere else but the end of the list. Insert will take index first. Remember, index will always be first, followed by the value. List name.index of X will give you the first index of X. So similar to remove, however, instead of removing, it'll just tell you the index. X in X space in space list will tell you if X is inside of that list. And len is a function similar to print. So you put len and inside you put your list name. Hopefully you all understand this better. Now we're going to go over iterating through loops. Oh yeah, and if anyone needs to take a screenshot, I'll go back for a second. This is where you want to take a screenshot of. I'll give you a few seconds to do that if you want. All right, if anyone wants that, please tell me in chat. Otherwise, I'll move on. Iterating with for loops. So we already went over for loops before with in range. However, now we have for variable name in list name. So instead of range, it's for variable name in list name. Before you do for variable name in range, now you do in list. So, and here you can code with variable name being each value in the list. So how does this work? Let's do an example with fruits. So here you have fruits, banana, apple, orange, and blueberries. And you have a for fruit in fruits. You don't need a bold, that's just so you see it better. Print fruit. So how does this work? First, the first line of code to be executed is this one. Now you have the list ready to go. And then you go on to here, for fruit in fruits. Now, at this point, you're defining fruit to be equal to the first element in fruits, banana. So here we go print fruit, and fruit at the moment is banana because it's the first one. Go into the next one, and it's going to be the second thing in this list, or apple. Now we define fruits as the third one, which is orange. Then, hopefully everyone can guess by now what the last one will be, blueberry. So you will have now you finish the code execution and you would have printed banana, apple, orange, and blueberry. So here are some independent prompts. These are rather complicated problems. And if you need help, please tell us and we'll try to help you. And we'll go over these problems at the end. By the way, for the first problem, there's a typo. Instead, it says write 4 functions. You only need to write 2 functions.
Let us know when you finish 2B. So do all of the questions till 2B and then let us know.
Also remember to, I'm going to let you guys know again, if you have any questions at all, we'll be happy to go over the problems with you. I'll go over these problems at 3:45 because we need some time for the next section. All right, because we don't want to run out of time today as well, I'm going to go over the problems right now. All right, so the first one is write for, well, it should be two functions, which take a list of numbers and return a list containing the following: positive numbers in the list, odd numbers in the list. All right, let's go to REPL. So it's a function, so we use def, function name, odd nums, which takes a list, L. Hopefully you all remember this from when we taught functions. And now we have to find all odd numbers in it. I'll do B first because I already wrote the function name. So how would we do this? Well, one way we can start is by defining another one. Let's call it O for odd. And let's make it a list, right? And here we can store all of the odd ones. Another way we could do this is by deleting all the even ones from L. So let's just try. For I in L. So what this will do is I will iterate through all of the values in L, as you remember from our slides. Then if I, how do we find out if it's odd? Well, mod 2, this is modulo, the percent sign, and it finds the remainder. That's just a fancy word for it. Equals equals, find out if it's equal to something. And odd has, or when you divide by 2, a remainder of, let's find out what. So 3 is odd, and let's divide by 2 and get a remainder of 1. 5 is also odd, and you also get a remainder of 1. So it's 1. Now we can do O dot append, because we just want to put it at the end, I. And if we try running it, print, and we also have to return, right? Return Oh, because that's the odd number one. So let's print out odd nums of this list. 1, 3, 2, 2, 5. Let's see what it gives us. 1, 3, 5. And that seems to be correct. Now let's just go over this one more time. So we create another array, spare or list. List and array are the same thing. They're just different ways of saying it. And then we iterate through everything using a for loop. Then we check if it's odd. And if it's odd, we append it. Now, another way we could have done this is instead of making this, we could have used del. So how would we do this? Well, if I mod 2 equals 0, this time we're checking if it's even, we can remove it. L dot remove I, and we can return out. Something seems wrong. Oh yeah, one thing that I forgot is using a for loop and deleting stuff is generally bad practice because of how for loops work internally and how deleting works. And it normally will not work that well. In some cases it might, but in this case it doesn't. So let's go on to the next one. Print positive. Now let's do the same thing as before. O equals a list for I in L. This will iterate through L. If I is greater than 0, so it's positive, O dot append to add to the end, I, and return O. This will give you the positive numbers. The next questions are find the sum, average, smallest, and largest. All right, how do we do this? And I'm not going to run this because the same thing as before, except with a different if statement. So how do we do the sum? Well, we create a variable. Let's call it s for sum and give it 0. This will be the sum up to that point in time. So when we start off, it has a sum of 0, and then we'll just add each element inside for I in L, and we can add it. S plus equals S plus I. What this does is I'll find the sum, and let's just call this something like sum, or list sum. And now we can add a return statement to get it so we can use outside. So let's see. Print this should give us 6. All right, it works. The next one is works well with this one. Let's find the average. For those who don't know, the average is, it's just, we have average and then so on. So average is the sum of all of the elements and divided by the amount of elements. So we already coded something to find the sum. We could just code this again, or we could use that again. So list sum of L, and let's just call it S. So this is basically doing all this code right here. If we found there was an error in this code, we could just change it here. We don't have to change it in both places. Now, the average is the sum divided by the amount of elements, which is length of L. And print what's the issue? There's an extra Oh, I forgot the colon. 2.0. And that does seem to be average. The smallest and the largest, I'll only do one because the logic is basically the same. So for this, how you do it is f smallest, let's not forget that. You just define the smallest so far, like before, with sum. Define the sum so far. Define the smallest so far, and then at the start, you define it to something really, really large. That's pretty large, and I'm pretty sure none of the elements inside of that will be larger than that. So then, for I in L, a for loop, we're iterating through each value in L. Then you do if S is greater than I, so if this is no longer the smallest element, if it's greater than something, then you make it the smallest one. Then you return. And it's 1, which is the smallest element. Now, the thing about largest is you would just swap this and make this something really small. I could just add negative, and it'll give you the largest one. And the next one is, all right, we're running out of time, so I'm going to skip this one. And just so you know, the reversal list, there is a built-in function. However, it is more educational if you program it yourself. However, if you want to, it's list.reverse. All right, now classes. And I'm going to give this off to Vedant.
Yeah, I'll load up my slides.
If anyone had any questions on the lists, now would be a great time to put it in the comments.
Okay, can you guys see my screen?
Yeah, we can.
Okay, so now we're gonna start with classes. Okay, so now we're gonna start with classes. We're gonna teach you today, we're gonna teach you how to create classes and put variables inside of them. So what are classes in the first place? So classes are a template which house variables and functions inside of them, which can be copied and filled out by instances. You can think of them as a custom variable type, which houses other variables. But this will be fleshed out as we continue. You might not understand it right now. So classes can be used to combine many variables and functions into one organized named variable type. So a dog class would house multiple variables inside of it. Its name, gender, breed, age, and size. It could have the name could be a string, the gender could be a string, its breed could be a string, and the age and size could be ints or floats. So you could do this with a student, which could also have a name, age, gender, and grade level in the same way as a dog. Then what you can do is you can have multiple students, and each student could have different name, age, genders, and grade levels, and you could store them all or use them all for different purposes. So this example, you have your template dog, which has name, gender, breed, age, and size. And you have these two instances. There's dog 1, which is named Cookie, and dog 2, which is named Dash. And they have different genders, breeds, age, and sizes. Then what you can do is later you can access these ages and sizes and breeds on each of them. So over here is an example of this done in code. So first, to create a class, you have your class definition. Over here, you have your class dog. Now we create a bark sound. Now once tabbed in, we define some variables here, which are defined like regular variables. You could even have lists in here if you wanted to. So you can have your bark, which could be set to like woof, and your initial tail size could be 5. Remember that these variables have to be defined. So you can't just leave bark and then nothing. It has to be bark equals something. Then what you do is create an instance. So an instance is like this class. It has the same variables inside of it, and those variables can be changed by that instance. So if I create this dog class, it'll have the variables bark and tail size, and they'll be equal to woof and 5 respectively. But then if I change it by doing lowercase dog dot bark, which accesses the variable, and then I set it to this bow wow 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 wow, and then I set tail size to 5 again. What it'll do is it'll change the instance's variables, so it'll just change lowercase dog, but it won't change the variables for the entire class itself. So if I create another dog, its initial values will still be woof and 5, not bow wow 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 and 5. So instances have their own set of variables, like local variables inside of a function, but every class has the same set of variables that are changed in each instance. So each instance is different, but they have the same set of variables inside of them. So if you want to use classes, you use them to store data that is unique to each instance of that class. So if you have elephants, 100 elephants, and you need to store them with all a different name, you would create an elephant class with a name. Instead of bark and tail size, it would just be name, and it would be called elephant. Then what you could do is you could create multiple instances of elephants and then change the name of that elephant. You could even do this in a for loop if you wanted to. If the names are all just like 1 through 100, you could do this in a for loop like that to index them off. It would be something like this, right? So if I have a class, so I'll start by creating my class, elephant, right? So you have your class, and then you have your class identifier, the name of the class, tabbed in, and then I can set up a name. And I could set up a default name, right? Maybe I'll set the default name to change. So because I need to change it. And then I can do this, right? So for, because you can loop through, so because I want to create, let's say 100 elephants, what I can do is for I, which will be my variable, in range 100, right? So it'll go from 0 to 99. What I can do is I can create elephant is equal to an elephant. So I'm creating an instance here, and then after that, I'm going to edit the name of that elephant, and I'm going to set it to I. So every time you'll create a new elephant, and their names will be from 0 to 99. Now, if I wanted to, I could store these elephants in a list. So I could create a list of elephants like this. And then what I can do is I can do elephants.append elephant. So what it's doing is that every single for loop iteration, it's creating an elephant, changing its name to I, so 0 through 99 as the for loop repeats. Then it's adding that elephant to this list of elephants. So now you're going to have 100 elephants with each a different name, right? So now what I could do if I wanted to is I could do for I in, we'll do this, right? So we'll do for elephant in elephants. Now we have access to every single elephant in elephants. I can print out elephant.name. And if I run this, I should get 1 through 99 and 0 through 99 because we set them all here to different names, and then we're printing them out over here. So you could use that. So that's one way you could use for lists. Classes combined with lists, combined with for loops, stuff like that. So the syntax of a class goes like this. So you have your class identifier, which works a lot like your def keyword, and then you have your name. You usually want to put this in uppercase. It's just a convention, but you don't have to, but it's good if you do. And then you have your colon, like everything else. Then to define variables, you tab in, and then you create your variables like you would any other variable, lists, ints, floats, strings, all of them go the same way here. But you have to initialize them, and you can't just leave emptiness. Then to create an instance, what you do is you define a variable like Bob, and then you set it to the class's name plus parentheses, like you're calling a function, but no parameters. You don't put anything inside of these parentheses. Then if you want to change those, then now what will happen is that instance will have the same variable values as the class. So Bob's name would be change this. And then what you have to do is redefine bob.name. So I set it to Bob. And if I print this out, bob.name will be Bob. So this is just the same thing. To show that relationship of you have to change those variables, I'll create the human class here. So if I create a class human, and then I set its name equals to change this, right? And then I create an instance, so Bob equals, my bad, human. Then if I print bob.name over here, it should be change this. And you'll see that it runs change this over here, because that variable name over here, the variable name, is not changed when you do that. But if I set bob.name to Bob and run it, it'll be Bob. And then even after that, if I create another, even after I set Bob's name, and I create another human called Rebecca, and then I print Rebecca's name. Let's say I put these two strings over here. So what will happen here is that you'll see Bob's name, and then a space, and then Rebecca's name. You should see change this after, because I haven't changed Rebecca's name from change this. And Bob's name is only inside of the Bob instance. So Rebecca's initial value will still be change this, even if I change Bob's name to Bob. So if I change Rebecca's name to Rebecca, then you should see that Bob's name won't change, and you should see Bob and Rebecca. So Bob's name will still say Bob, and Rebecca's name will change. So now, do you guys have any questions about that? I'll give you some time to ask any questions. Don't be shy about it. It's a bit of a confusing concept, I know. It took me a while to grasp it too. Okay, so if you guys don't have any questions, we're gonna start with some practice problems. So our first practice problem is gonna be creating an elephant class that has a name and a weight. And then after that, we're gonna create functions to subtract, divide, add, and multiply the weights of two elephants. So how do we start with this, right? First, we're gonna wanna create our elephants. I want you guys to code along with me for these ones so that you guys can see things working. So open up REPL. I'm going to give you guys some time. Tell me done once you've opened up REPL. Yeah, can you guys put done in chat if you guys have opened up REPL already on the side? Okay, we'll wait for a bit while everybody opened up REPL. And yeah, you guys can always just ask anybody privately any questions about the topic, and we'll be happy to answer you. I'll give you guys like 3 more minutes to open up Ripple and open up a new project. Okay, I hope you guys have opened up REPL because I only get 6 done, but I'm going to have to continue right now. So we're going to start. So we're going to start by creating our elephant class in the first problem, right? So first we're going to create the class elephant. So you're going to want to create your class identifier and then a space and then the word elephant. So, and then you're going to want to have a colon. Try to keep your classes uppercase. It can be lowercase, but uppercase will be nice so that you can create lowercase variables later. Then press enter and you should be tabbed in on the next line to start creating variables. So to create a variable of name, we first type in the word name and then we put in our equals and then we put in our initial value. If we want to, we can just call it some random thing. We can just make it like that or something if we want to. And then we also want to have a weight. Then over in weight, I don't even know if I'm spelling weight correctly, but it's okay. It doesn't really matter. Then you can give it an initial weight value. You're probably going to want this to be an int or a float. So if we want to, we can just do something like 0.0 for our initial weight. And that should complete the class. We don't have to worry about this. And this will give us our initial class. Now we're going to want to create, let's say, 2 elephants that we want to compare, right? So let's create, you can name these anything you want to, but you're going to need to create 2 instances. So let's say we have an elephant named Susie, and then an elephant named Momo. But these 2 elephants, their values are still going to be, they're still going to be named, and their weight is still going to be 0. So what we're going to do is we're going to change this. So let's first set Susie's name. And then let's name her Susie. And then let's set Susie's weight to, let's say, 16. Now, can you guys type in chat how I would define Momo's variables? So I want you guys to like give an example of that. Okay, anybody want to put in how they would define Momo's variables? It's just like we did Susie's. Oh, man, okay. If nobody wants to do it, we'll just continue. So we'll start with Momo's name, and we'll just name him Momo. And then we'll put in his weight. And let's say we want Momo's weight to be 15.3. And just for the sake of keeping it all decimals and consistent, we'll put Susie as 16.0. Right, so now what we want to do is we want to create functions that add, subtract, divide, and multiply these weights together. So we're going to want to take in, so we want to start with let's start with our first function, right? Let's start with add, and I will name it add underscore weight. That works. I forgot, you've got to put in your def keyword, and then let's start with add underscore weight. And then we will start by giving it two parameters, elephant1 and elephant2. And then we'll put our colon and tab in to start our function. So to access the weights of each of these elephants, we have to do it the same way we define their values, by doing the first elephant1 dot weight. And then if we want to add these together, we can put plus elephant2 dot weight. So we're accessing these variables, so elephant1's weight and elephant2's weight, and we're adding them together. And then what we can do is, so that this function gives us a value back, we can return that out. So now if we input, let's say now if we go over here and then write in add underscore weight, and then we input Momo and Susie, we should get the adding of 16.0 and 15.3. So let's print that out. And we'll get 31.3, because 16 plus 15.3 is 31.3. And now we can use the same principle to do subtract, multiply, and divide. I want you guys to try to do subtract, and once you guys are done, type done in chat, and we'll move on to multiply and divide. So yeah, try out subtract on your own. It's the same deal as add weight, except you're just going to change the operator in the name. And I just want you guys to try that out. I'll give you guys 2 more minutes to think about it and try to do it. Are you guys confused? Are you guys having trouble about thinking about what to do? Can you guys type in chat? Okay, I'm gonna continue. I'll show you guys how you're gonna do the subtract. So to subtract their weight, you write another function. Let's say subtract underscore weight, right? And you take in the parameters, elephant1 and elephant2, just like your add function. And remember that these are going to be elephants. You tab in, and then you can do return because you're going to be returning this statement. And you can do elephant1.weight minus elephant2.weight. So what it's doing is that you're getting these two elephant parameters, and then you're subtracting the second weight from the first weight. So, and then you're returning that out. So if we do subtract underscore weight and we press run, it's going to subtract their weight. So if we do Susie for Momo, we're going to get a negative value because Momo's weight is less than Susie. So what's happening here is that subtract weight is putting Momo as elephant1 and then Susie as elephant2, and then it's doing Momo's weight 15.3 minus Susie's weight 16.0. Then you can do the same thing for multiplication. You would do the same idea. You start with your parameters and you create your function here, and then you return the value elephant1.weight times elephant. Instead of doing subtract or add, you do multiply. So your asterisk key. So then what it'll do is if I put in Momo for elephant1 and Susie for elephant2, it'll do Momo's weight 15.3 multiplied by 16.0. So if I change this to multiply weight, it'll give me the value of 15.3 times 16.0. Then for divide, you're going to want to do the same idea. Except, so you want to take in your parameters, take elephant1.weight, and then divide divide it by elephant2.weight. And then if I do that, and then instead of multiply, I use divide, I'll get that, which is 15.3 divided by 16.0, because elephant1 is Momo and elephant2 is Susie. So, I don't know, maybe that's a bit confusing for you all. We're going to do more examples. So yeah, let's continue on. This example might be a bit harder, but it's going to keep on telling you how classes work. So what we're going to do is we're going to create a, so actually first I'll create a new REPL so that I can do more things. So what I want to do here is I want to create a dog class, create 5 dogs, and put them in a list. Then I want to tell the user which dog is the heaviest. So we can split this up into multiple parts, right? So we can split this up into the definition, whoops, I forgot, so to create comments, you want to put a hash. So we can split this up into the definition of the class. And then what you're going to do is we're going to create instances, create 5 instances of dogs. And then you're going to, and so these instances will have them. And then now we have to put them in a list. So we use list.append, and then we put the dogs into a list, right? And then after that, what we're going to do is now that we have those dogs inside of a list, we're going to want to compare them all to see which is the heaviest. So the last step is going to definitely be the hardest, and it might be some new sort of thinking for you guys, but if you guys can grasp this problem, I'm sure you guys will be able to grasp a lot more. This problem is pretty important, and it's going to be pretty hard for you to understand at first, but I urge you to at least stay with it, think about it a bit, and code with me, please. Maybe try to go one step ahead if you can, but I urge you to code with me. So we're gonna first create our dog class. So we're gonna put in our keyword, and then we're gonna do our uppercase dog, and then our colon. Press enter, we're tabbing in. And then now we just want to have a, we're going to want to have name, gender, and weight. I mean, we don't really need name and gender for this activity. So we're just going to simplify it and stick with just weight. So we're just going to have you're just going to have a weight variable. So you have your weight here. And then we're going to define this initially to 0. Okay, so now we have our class, and this class has the variable weight. And you know what? We'll put in a name just for measure. And then we'll create this name to initially to be changed, because we're going to want to change it when we're creating instances. So now we want to create 5 dogs. So let's create a dog Spot, a dog Lisa, Dash. So I'm just creating multiple dogs and naming them different things, just the variable names. I'm not changing their parameters yet. We'll change that soon. And then we'll create Hector. And then if you wanted to, you can name these dog 1 through 5 if you want. It's up to you. We'll name this last one Toros. So now what we'll do is we'll change the weight and name of each of these. So we'll start with the weight because that's the most important one. So now we can set Spot's weight to, let's say, 1. We'll just make these 1 through 5 so that it's easy to see. What we want. And then we'll set Dash's weight. And then we'll set Hector's weight. So just the class's name plus dot weight, which is the variable name, and then you're setting them just like a regular variable. And then Toros, we'll set it to 5. So now we have 5 dogs with 5 different weights, and we know initially that Toros's weight is the heaviest, but we want the program to know that so we can put in any weight in any order so that it'll work. Right, so now let's just put in these names just for good measure, just because it'll help differentiate them. And it's the same thing as the weights, except now we're just putting in names instead. So you can just put the same name as the class name, or you can create whatever names you want. Oh, whoops, I just put dash.name. Remember to put the instance's name that you want to name over here. Don't do any, if you want to set Toros's name, you have to do Toros dot. You can't do Hector dot the name, because that will change Hector's name. So now I have 5 dogs. Each of them has a different name and weight from 1 through 5. And they're named Spot, Lisa, Dash, Hector, and Toros. Now, what we're going to want to do is we're going to create a list and add the dogs to it. So to initialize our list, we're going to create the list of dogs, and then just put the 2 brackets like that. Then, to add them to that list, what we're going to want to do is do to append to the list, we're going to do dogs, our list name, dot append. And then we're going to want to add these objects. So let's start with Spot, and then we'll append Lisa, and then we'll append Dash, Hector, and Toros. So now you're going to have this list of dogs that's going to have Spot, Lisa, Dash, Hector, and Toros in that order, because dot append adds to the end of the list. And now is the hard part. comparing them to see which is the heaviest. So if you're comparing two objects, you can always just use the greater than or the less than symbol, right? But now that you're comparing 5 things, you can't just continue to, if you want to compare an entire list, no matter the length, you're going to want to think about it a bit differently. So one approach to it is this approach. So you save a variable, right? I'll show you this in a second, but I'm just explaining it out. So you create a variable. It's a temporary variable that'll save the current heaviest dog. Then as you loop through the list in a for loop, what you can do is you can check each dog versus the current heaviest dog. And if that dog is heavier than the current heaviest dog, that means the dog that we are comparing, the dog that we are on right now, is the heaviest dog. So then we set that temporary heaviest dog variable to the dog that we're iterating on right now. So I'll show you this right now. So then once you're at the end, you will have the heaviest dog in the list because it's been compared against all of the other heaviest dogs. I'll show you this as we go. So what we'll do is we'll start with a temporary heaviest dog variable, right? And we'll set it to a value. Actually, in Python, you're going to want to do underscores. So temporary underscore heaviest dog. And we'll initially set it to dogs 0. So that means that the original dog that we're looking at, is technically Spot. But so we're just setting it to Spot right now, just temporarily. Then what we're going to do is we're going to create a for loop, right? So for dog in dogs. Now this will go through every single dog and put them into the dog variable like the for each loop does. Then what we can do is now we have this temporary heaviest dog and we have this current dog inside of the dog list. What we can do is we can write an if statement. So if dog dot weight is greater than temp underscore heaviest dog dot weight. So this is checking whether the current heaviest dog's weight is less than the dog we are iterating on. Then we want to do something. So now we know that this dog's weight is greater than the current heaviest dog's weight. That means that we want to set the dog that we are on right now to the current heaviest dog. So to do that, we can just do temp underscore heaviest dog is equal to dog. So this is setting temp heaviest dog to this current dog variable. So now this should give us the heaviest dog at the end. So if I go through this, I'll show you this right now. So if we do this and then we print the heaviest dog dot name, you should see Toros. So why does this happen? Why is Toros the heaviest dog? And let's say I make Hector the heaviest dog. I may put him to 6. It should give you Hector. So why? So let's think about it. So let's say we're looping through. We start with the first dog, Spot, right? Then what's happening is that it's checking the current dog. So we start with Spot as the dog variable, and temp heaviest dog is also Spot. So if Spot's weight is greater than Spot's weight in this current situation, it's false. So it goes to the next dog. So now it's asking, is Lisa's weight, so the next dog, is it greater than the current heaviest dog, which is Spot? Yes, it is. So then it sets the current heaviest dog to Lisa. And then it goes through back, and then it puts dog to Dash. So now it's checking if Dash's weight is greater than Lisa's weight, because Lisa is the current heaviest dog. So because 3 is greater than 2, now it sets the current heaviest dog to Dash. And now it goes to Hector, and then it'll check, it's checking whether Hector's weight is greater than Dash's weight, because Dash is the current heaviest dog. And because it is, then Hector becomes the current heaviest dog. And let's say that Toros's weight isn't greater than Hector's, right? Then it's checking whether Hector's weight, whether Toros's weight, because they're on the last dog right now, you're checking whether Taurus's weight is greater than Hector's, which is the current heaviest dog. And because Taurus's weight is 3 and Hector's weight is 4, meaning that Taurus's weight is less than Hector's, then it won't run this code, and the 10th heaviest dog will still be Hector. So at the end of it all, the greatest dog will always be the dog with the greatest weight. So even if I add a 6th one over here, it will always be the same. Are there any questions on that? That one's a bit confusing, but I want you to like have that sort of deal. It's an important problem to go through. Okay, so now we are going to continue. Now we're going to continue on to some independent problems. This is going to be easier than the last problem I just asked you, but they might be a bit hard. So I'm just going to leave these on my screen. So your first one is going to be creating a train class with an integer, with just one integer with the number of cars there are inside of it, and then create an instance of the train with a different number of cars inside. And then you have to tell the user how many cars are on the train. So you have to just access the train.cars variable. And your second one, you're going to want to create a dog class with name, weight, and length. And then ask the user to input a name, weight, and a length. And then create an instance of the class with the user's inputted values. We're going to give you guys like 10 to 15 minutes. And I think after we're done with these, we're going to finish off the class. Unless somebody else wants to do something. Once you guys are done with, if you guys have any questions, just ask anybody with Paly Robotics, or just me, anybody like that. And if you guys are done with a problem, just type it in chat.
Let us know when you're done with question 2 in the chat.
Also, please ask if you're stuck. I can't help you out if you don't ask. How much more time do you guys? Okay, we're gonna have to end the class soon. If you want to, you can leave. Awesome, dude. That's great. Nice job. If you guys want to, you can leave. But if you guys want 5 more minutes or so, I'm gonna stay on screen sharing with the problems so that you guys can continue on them if you want. But if needed, you can leave.
By the way, there's nothing wrong in asking for help. It shows that you're engaged and it shows that you're working hard. So it's a positive thing to ask for help where necessary.
Yeah, I'll give you guys till like 4:55, and then I've got to go after that.
All right, thanks for coming, everyone. Next session is on Wednesday, and then in the second session on Friday we'll be making a hangman game. So yeah, that should be a lot of fun. Thanks for coming.